Alright, target 7C is use the characteristics of similar figures to justify the trigonometric ratios. So, prove that sine C and sine D are congruent. And we have told you that sine equals opposite over hypotenuse. Again, that won't necessarily be on the test. So, remember, S equals O over H, right? All your SOHCAHTOA stuff. Okay, so I want to find the sine of C. Alright, so again, I have my hypotenuse. I'm looking at C, because that's what it's asking for here. So I have my opposite side and my adjacent side. So sine of C equals opposite over hypotenuse, which is 6 over 10. This does reduce to 3 over 5. Okay, and you can check that in your calculator. Then, sine of D, right, I'm looking at this angle. So I have my hypotenuse, the opposite side, and the adjacent side. So over H, again, 3 over 5. This doesn't reduce, but yes, these are equal. So I'm just going to write that. Sine of C is equal to the sine of D. Right. Remember that when you have those similar triangles, your trig ratios are equal. We're also going to use that fact in number 12, right? Again, these are similar triangles. So the cosine of A is 11 over 61. So what is the cosine of D? Well, they're the same angle. These angles are equal. So the cosine of D equals the cosine of A, which equals 11 over 61. That easy, right? Again, number 12 is just making sure you recognize that those are going to be the same. Okay. Same thing with 13. 13 is almost exactly the same, right? I want to identify the sine of D. Okay. These here. I don't have enough information about this triangle to tell what this sine of D is going to be, but I know the sine of D is going to equal, right, this triangle since they're similar, okay, which equals the sine of A. Sine is, again, opposite over hypotenuse. So, looking at the sine of A, right, I have hypotenuse, opposite, and adjacent. So my opposite side is 35, and my hypotenuse is 37. Okay, so again, just recognizing that those two triangles are going to be the same. They're going to have the same trig ratios. Okay. All right, looking at number 14. Given the right triangle, answer parts A and B. So I'm going to find the sine ratios of the corresponding non-right angles for triangle ABC and triangle DEF. So I need to find the sine of all the angles except the right angle. That's basically all it's asking. I'm going to tell you, these are not going to be given to you on the test. You're going to have to know which angles to find. Again, it's just the ones that aren't the right angle. Okay. So sine of A is here. So I have my hypotenuse, the opposite, and the adjacent side. So again, sine is opposite over hypotenuse, which is, in this case, 5 over 13. Now, I want to look at angle B. Remember, your opposite and your adjacent switch. So, sine of B opposite over hypotenuse is 12 over 13. Okay. Now, looking at my other triangle, I'm going to start with sine of D. Okay. So, I have the hypotenuse, the opposite side, and the adjacent side. Okay. So, sine of D is opposite over hypotenuse, which is 35 over 91. I'm going to type this in my calculator, see if it reduces. And it does, to 5 over 13. then sine of E. So same thing, right? When I switch to my other angle, all right, my opposite and my adjacent side switch. So when I have opposite over hypotenuse, I now have 84, right, over 91. Again, check those reduce. Ooh, 84 divided by 91 is 12 over 13. So then, B, explain how your results from number 4 support the triangles being similar. Okay. So I do have sine of A equals sine of D. And then sine of B equals sine of E. So if trig ratios are equal, triangles are similar, right, by angle. Basically what you're telling me is since this A is equal to D and D is equal to E, so you have your angles that are equal, so the trig ratio triangles are similar by angle. Alright, and that's it for that one. So let's look at number 15, the last one for this target. Given two similar right triangles, we have ACD. That's not right. I think it's fixed. Maybe it's not fixed sometimes. This is a typo. Triangle AED is your first one, and triangle ACB. This is the triangle symbol. Okay, so triangle AED and triangle ACB. Yes, I fixed the angles down here. I forgot to fix the names. That's okay. So our first question is to solve for y. Okay, so y is part of this red triangle. So all I'm going to do to solve for y is I'm going to use Pythagorean's theorem. Okay. So I have a squared plus b squared equals c squared. I have 5 squared plus 12 squared equals y squared. 5 squared is 25. 12 squared is 144. These are on the same side, so I'm just going to add them. You get y squared equals 169. When I take the square root, y equals 13. I'm going to put that in there. The next thing I'm going to do is solve for x. X is part of this blue triangle. Okay. And I know the length of this blue triangle, right? This is something we looked at last unit, and we continue to look at this unit, right? This whole side is 52 plus 13, which equals 65. This whole side is 20 plus 5, which equals 25. Okay, so don't forget you have to look at the whole thing. So if I'm solving for x, I'm going to do x over 12 equals, and then I just have to choose one other side. So this was on my blue triangle. I'm going to go up here and do 65 over in my red triangle. I have 13. Okay, so again, matching up those sides. So then I cross multiply, and I have 13 times x equals 65 times 12. So 13x equals 65 times 12 is 780. Divide both sides by 13. And x equals 780 divided by 13 is 60. Okay, so then our last question is the sine of angle ADE equal to the sine of angle ABC. So let's start with the sine of angle ADE. ADE is here, so here's that angle. Okay. So across from the right angle is my hypotenuse, my opposite, and my adjacent side. So the sine of angle ADE equals opposite over hypotenuse. The opposite side is 5, and the hypotenuse is 13. Okay. And then, let's choose another color. Choose orange. For ABC, okay, so A to B to C is here. So again, across from my right angle is my hypotenuse, opposite, and adjacent, right? I'm making sure to look at my blue numbers here that are all the big numbers all the way on the outside. Okay. So sine of angle ABC, again, equals opposite over hypotenuse. My opposite side is 25. My hypotenuse is 65. That probably will reduce because they both end in 5. And I get 5 over 13. And look at that. Yes, they are equal. So the sine of angle ADE is equal to the sine of angle ABC. Alright, that is it for target C. Go ahead and work on target D.